All right, let's go over. This is 10.3, I believe, numbers 3 to 11. Now, each one is like their own type, so let's talk about that. Number 3 to 5. So one thing that we talked about is that if the chord inside the circle are congruent, that means the arc that it cuts off is congruent. So for example, if ED right here has the same length of the chord here, so this line is congruent to mark it in yellow over here, that means that the arcs are matching also. And we could tell this part because the center angle is 75 degrees, that means the arc angle is 75 degrees. So this one should also be 75 degrees. Very straightforward, but the problem is just how do we know that? We know that because the chords are equal. That's the only way we actually know that. Okay, next one. So this one, this is 34 and this is 34. So since they're both 34, we could say they're congruent to each other. Also, we know this arc is 128. The issue is I don't know what BD is. I don't know what ADB is. So I need to figure that out. But I do know a full circle is 360. So I could do 360 equals this part AD, so that's 128, plus AB plus DB. Now DB and AB are the same length because they both have a chord of 74. So if I call them X, I could write 2X. Because they're the same, so it's X plus X, 2X. Because I don't know what they are, so I just put X. So we do a little math. Subtract 128 on both sides. You get 32 equals 2X. Divide by 2 on both sides. 116 equals X. Which means AB should be 116. This arc right here is 116 degrees, I should say. Okay. Next one, number 5. Here's a rule or a law or a theorem or whatever. It's a theorem, actually, I should say that. If you have a diameter and it's perpendicular, that means that chord is being bisected. The reverse is true also. If it was bisected and perpendicular, then you know FH is a diameter. Regardless, that means that this piece right here, JE, should match GE. So if this one's 8, this one's also 8. We know that because it's a diameter and it's perpendicular. That's how we know it's being cut in half. Slash, they're both the same size. Okay. So these 3 examples are just the rules applied of chords and stuff. So let's go to number 6. Number 6, and this, as I was saying earlier to the guys who came early, this is just a straightforward section because everything's basically equal to each other. Again, BD is a diameter and it's perpendicular. So this is congruent to that. If they're congruent, then I could put the measurements equal to each other. 4X equals 3X plus 7. Subtract 3X on both sides. X equals 7. Straightforward. Number 7, 5X minus 6. This, again, bisecting because it's perpendicular in diameter. So they're equal to each other. So 2X plus 9 equals 5X minus 6. I'll probably subtract 2X and plus 6 on both sides. So I get 15 equals 3X. I'm doing it a little quickly just to save you guys time. And I don't hold you on too long. Divided by 3 on both sides, X equals 6. Okay? All right. Number 8, how are we going to tell that these are equal? We could assume they're equal. Like, there's nothing else it could be. But how do I know for a fact? Well, this US is a diameter, right? So that means QS is a radius. Also, QT is a radius. And what we know about radii is that they're always the same size inside the circle. Whether it looks like this, or like this, or like this, or like this. They're all the same size. Which means, if these both are the same size, then we know we can set them equal to each other. It feels like kind of like our old, I don't remember which chapter, but when I said like, when in doubt, to set them equal to each other, it's kind of like that in this section. So 6X plus 9 and 8X minus 13. So the reason I want you here, guys, is not simply because to do the math. I just want to explain why they are equal to each other versus just telling you they're equal to each other. So plus 13 minus 6x. So it looks like I get a 22 equals 2x. Divided by 2 on both sides, x equals 11. Okay? All right, number 9. Again, this is a different rule though. If you have two chords that are perpendicular and the same distance from the center, so what does that mean? That means that this little line is the same distance as this line here. That means the two chords are not only congruent, but they're also being bisected right here. Or this is a midpoint, however you want to say it. Again, when in doubt, set it equal to each other. So this is 18, this is 5x. So 18 equals 5x minus 7. Plus 7 on both sides, that's 25. Divided by 5, x equals 5. Okay, again, straightforward. Number 10, though, this is tricky. And then number 11, I'll... Actually, you know what? No. Number 10 is tricky because what they're giving you is that right here, they only give you half of it. So what does that mean? You either have to
use 11 instead of 22.
Good. So there's two things you could do. So sometimes, though, let's say if they gave you an equation from BC, like, and then they give you this as a number, you could either cut this one in half or double the equation. So I could also do like this to times 2. But because this is a whole number, it's easier to cut this in half.
Can you explain why you can't just do 3x plus 2 equals 22?
Because look at the blue line they're asking us to find. They're only asking us to find this piece right here.
Okay.
If they asked you for the whole thing, you would just do equal 22. So 3x plus 2. Solve that. That's going to be minus 2 on both sides is 9. 9 equals 3x. That's going to be x equals 3. All right. I assume everyone expected this. Number 11, I want you to do yourself. Like I said before, if these distances are equal, then you know the lines are equal. The reverse is true also. These chords are equal, so you know these two little lines in between are equal. Should be a fraction, I believe. As soon as you type it in, I'll say your name, and you should be go. Then Daniel, then divide it. So what is the fraction? Yeah, just type in the fraction. And again, just privately message me, and once I see it and I say your name, you're good to go. If you want to say a little after for questions, that's fine. What's up, Samson? It says you raise your hand. I don't know that. Is that on purpose?
I have a question, Mr. Tobal.
Who is that? Daniel?
Yeah.
Yeah, go ahead.
So when you're doing 3 to 5, with the chord, I thought it would just be that line that it like the line that it says it'll equal would be equal. Like the 75 would be equal to just the line, not the whole, like the whole angle. Like the whole.
No, 75 is an angle, and this is an arc angle. So kind of like, it's also an angle, essentially. This line is some distance. We don't know what the distance is. All we cared about is that it was equal, AED was equal to AB. And I see your guys' answers, so let me read them off. Daniel, you're good. You got the answer. Callie, you're good. You got the answer. Jason, you got the answer. Abby and Hoovy, check your work. Check your work.
Have a nice day, Mr. Tobal.
No problem. See you around.
Oh, wait, also, do we need to know how to solve it? Like, I heard what you were saying, but I don't really know the reasoning for all of it.
I mean, when in doubt, set it equal to each other, but just rewatch the lesson or rewatch this and you could check it out again. Okay?
Thank you.
No problem. Zach, good job. Michelle, good job. Abby, you got it this time. So Abby, good job. You're good to go. Hoovy, you're good to go. I'm just going to stop recording because we're kind of done.